Titan at visible wavelengths looks like, as everyone has seen, a orangey, hazy moon.
Another big mystery in the solar system is hidden beneath the orange clouds that cover Saturn's moon Titan. There is a world down there that is a lot like ours. It feels strangely familiar, while also being strange and hard to understand. Of course, the only way to be sure of what's going on out there is to land on the moon and find out for ourselves. With their planned Dragonfly mission, NASA will do just that. They will send a nuclear-powered helicopter to fly around Titan and look for signs of alien life. We are amazed by what we know about Titan. This moon is the only one in the solar system that has an atmosphere, and it's 4 times denser than Earth's. Like Earth, Titan's atmosphere is mostly made up of nitrogen. However, unlike Earth, where oxygen makes the atmosphere pleasant to breathe, Titan's atmosphere is also full of methane.
About Titan's atmosphere, we discovered a new molecule which hadn't been previously detected,
which is also known as natural gas. The thick atmosphere blocks out what little heat from the sun can get this far, making a negative greenhouse effect. As we get closer to the top, that methane gets colder and colder until it melts into water droplets that fall on a rock-hard layer of ice. Titan is now the only known world besides Earth that still has an active hydrological cycle and steady liquid on its surface. This is because methane flows through its rivers, lakes, and seas. Titan also has different settings, just like Earth. Along the moon's equator, there are both rocky seashores and huge fields with long dunes made by the wind. But this isn't sand, it's a granular biological matter that fell from the sky and landed on top of the rock of frozen ice. There is no solid answer to the question of what this stuff is, where it comes from, or whether it might be able to support life in the right conditions. Titan has a lot of water, which is good for life. Under the surface, there is an ocean of water that is mixed with a lot of salt to keep it from freezing. From time to time, water will rise to the top like slushy lava from a cryovolcano. The moon Titan doesn't have many impact scars either. This means that the surface of the moon is always changing and growing. Just like Earth, water, nitrogen, carbon, and organic chemicals are all things that are needed for life as we know it. The only thing about Titan's environment makes it seem like life, at least not life as we know it, couldn't live there. However, we agree that there are still many things we don't know about the world and life. So, we hope that our trip to Titan will give us new information. This is not the first time we've been to Saturn's faraway moon. We think we know everything we know about Titan from the Cassini probe, which was sent to Saturn in 1997 and studied the system from space for many years. But Cassini also brought a very special extra, a lander named Huygens, after the Dutch scientist who found Titan in the night sky for the first time. It's not possible to study Titan from far away because of the thick haze that covers the whole moon. The time has come to get close. Huygens was dropped from Cassini over Titan, and the lander started to fall into the atmosphere, which is thick and high. Its name, Titan, comes from the fact that it has a lot of atmosphere, which made us think it was much bigger than it really is. Huygens stayed in the air for 2.5 hours after its parachute opened, floating down to Titan's surface. You can see these pictures because the plane finally broke through the thick smoke and landed. Remember that these pictures were taken with a digital camera in the mid-1990s and sent live to Earth from more than 1 billion kilometers away with the help of the Cassini probe. The picture quality isn't great, but we can see the icy rock walls that have been cut through by rivers and streams of liquid methane. He lands on the soft, sandy bottom of a stream that has dried up. Before it shut down, the last thing it saw were these rocks. They were smooth and rounded from weathering, like river stones on Earth, but they were made of solid ice. Of course, we need to go back to Titan's surface to find out more. This is the reason NASA made the Dragonfly robot. The rover is different from the ones we've seen before. This one looks more like a current quadcopter drone. Mars is the only other planet where we've actually flown something. Its atmosphere is less dense than Earth's, so it has 37% the gravity of Earth. It was a happy surprise that NASA was able to fly their Ingenuity drone at all. Ingenuity was able to finish 72 missions on Mars during its 3-year stint in service. At that point in time, NASA learned a lot about flying drones from millions of miles away. They are now using everything they learned on the Dragonfly project. They are going much bigger this time, and a bigger drone needs a bigger power source. Ingenuity got its power from a small solar screen, but Dragonfly will be too far from the sun and have too many clouds to get power from it. NASA has to use nuclear power to study Titan. This is the same source of power they've been using for Mars rovers since Curiosity in 2011. It's not a nuclear generator like the ones you may have seen in power plants. A radioisotope thermoelectric generator is used by these deep space explorers. It is made up of a piece of radioactive plutonium that breaks down and creates heat. This heat is then turned into energy by the generator. It's just over 3 meters long and weighs about 450 kg on Earth. However, Titan's gravity will only be 14% as strong because it is so small. This is very close to the gravity of Earth's moon. Titan has very little gravity and a thick atmosphere, which makes flying a very easy and quick way to get around. Dragonfly is also an octocopter. It has 8 motor blades, and each one is just over 1 meter across. With this design, there is some redundancy. The machine doesn't need 2 propellers on each corner to fly, but if one breaks, the operation won't be held up. That's important, because NASA needs to work on this for a long time and spend a lot of money on it. Since 2017, Dragonfly has been in the works. It's an improvement on an earlier plan that would have sent a balloon to float around Titan. It can be hard to set dates for space projects that are very complicated. But Dragonfly is set to launch in July 2028, and NASA has already reserved the SpaceX Falcon Heavy for the job. Even with a rocket as strong as the Falcon Heavy, it won't be easy to get to Titan in an acceptable amount of time. They are going to send the probe to Venus first. Then, Dragonfly will use Venus's gravity to speed up its trip around the planet. After that, it will go back to Earth, do another gravity assist rocket to speed up even more, and then finally start its journey to Titan. It should take 6 years to finish this whole process. The Dragonfly will get to Saturn in 2034, which is 1.2 billion kilometers away. I think the last approach to Titan will be a straight ballistic entry, which means the spacecraft won't go into orbit and then slowly fall. We are launching a huge rocket at Titan. After being taken away from the engine of the cruise stage, the entry capsule is just a heat shield with a dome-shaped cover on top. This heat shield will be a lot like the one NASA used for the Perseverance rover when it arrived on Mars in 2021. The first time of stress should be the heating phase of entry, which should last for about 6 minutes. Then, just like with Mars rovers, once the probe enters Titan's atmosphere, a fast drogue parachute will open to slow it down. Dragonfly will spend 80 minutes falling on its first parachute during this phase, which should be pretty calm. The heat shield will be thrown out, and the main parachute will open once it's going at a comfortable speed. Another 20 minutes are spent on the last descent phase. At 1.3 kilometers above Titan's surface, things start to get tough again. Dragonfly won't land with its parachute. Instead, it will separate from its parachute and use its own propulsion system, just like the most recent Mars landers. This has been rocket engines on Mars, but it will be blades on Titan. Let this drone go through its paces, either it works right away or it falls apart. But Dragonfly will hover down for a soft landing on Titan's surface if it works. The landing zone is in an area called Shangri-La, which comes from the name of a made-up place in the Tibetan mountains from James Hilton's 1933 book Lost Horizon. That was a smart choice, since this part of Titan looks a lot like Arrakis from Frank Herbert's Dune series. Dragonfly will land on a flat plain surrounded by huge waves that have been blown around by the wind. These dunes are about 1 to 2 kilometers wide and 100 meters high. They go on for hundreds of kilometers. On Titan, the sand isn't made of silicates like on Earth, it's solid hydrocarbons that fall from the sky. It's kind of like very hard, grainy snow, but this snow is made from gasoline. These carbon-based grains are called organic substances because carbon is the main building block of life as we know it. It doesn't mean they are alive, but it does mean they could become alive in the right conditions. We still don't know a lot about those conditions, but if these organic substances are mixing with Titan's water below the surface, then there could very well be life there. That's the first thing Dragonfly will look into though. Even though the drone can fly, the most important research it does will be done on the ground. Dragonfly's main tool is a drill that cuts into the ground to break up frozen ground and create loose dust that can be sucked into the drone like a vacuum cleaner and sent through a series of tubes to a device for collecting samples. Each time Dragonfly gets a sample, it puts it in its own small container. The container is then taken inside to a machine that will use a laser to break the sample down into its individual molecules. This makes it possible to identify each one. Then, if the sample's molecules look particularly interesting, the container is taken to an oven inside Dragonfly. This turns the molecules into a gas that can be broken down further, sorted through, and studied for its specific chemistry. Biosignatures are exactly what scientists are looking for. These are signs of very early bacterial life. The idea behind this is that the conditions on Titan are a lot like what we think the early Earth was like, when hydrocarbons fell from the sky and mixed with water to make the primordial soup from which all life began. At least that's the idea. Dragonfly will hop across the surface of Titan, flying over dunes and landing in the valleys between them for 3 Earth years, or 764 Titan days. Dragonfly is going to go more than 180 kilometers and see 24 different places. Dragonfly will take off once a Titan day, which is every 16 Earth days. It will travel through the light and then land to collect samples and study them until dawn. In other words, it will spend most of its time on the surface, measuring things and sending information back to Earth. The mission starts in the desert with sand dunes, but the last few days will be spent exploring a large crater called Silk. It is thought that organic compounds mixed with liquid water after an asteroid hit and broke through the ice barrier. The methane seas are the only interesting place that Dragonfly will not be going to. There's a good chance that the drone won't even touch any of the top liquid, which is a shame. It's thought that Titan used to have rivers and lakes covering most of its surface. But over billions of years, the liquid has moved almost all the way to the moon's north pole. That's where we would have to go to find it, and sadly, landing at the polar regions of a planet or moon is about the hardest thing you can possibly do. We are still really fighting just to land at the south pole of our own moon, so trying the same operation 1 billion kilometers away on Titan would be too much of a risk. Going that far and then crashing would be a disaster for NASA. So landing at the equator is the simple answer, and with a mission of this size, simplicity is the key to success. It's not like Titan is going anywhere. We don't have to do all of the science all at once. In a decade from now, who knows what scientists and engineers might be capable of. We'll have new technology, new rockets, and more capabilities to send even more amazing machines out into the deep solar system and find things that we never even dreamed possible. But Dragonfly is really an amazing first step toward extending our reach far beyond Earth, and that is something really cool to look forward and discover their lasting impact as humanity's cosmic ambassadors, carrying our messages to the stars. Thanks for watching.